So the goal here for using matrices with systems of equations is to actually solve for your x, y, and z. So we kind of walk through a big long process of like starting with the matrix equation. Then when you guys multiply both sides by the inverse, it disappears on the left-hand side. But then you still have to do it over here on the right-hand side. So at this point, when we ask you guys to solve a systems of three equations, we will just give you the inverse matrix. So like notice the difference between the wording. It's not asking, is this the inverse matrix? It's telling you, this is the inverse. Let's use this. So up here, what I had written before is what we actually write down to solve for your systems of equations. So if you're solving for x, y, and z, and like I said, it just depends on what variables you guys have. Usually it'll be x, y, and z. It could be ABC, could be RST, could be PMW, I don't know. But whatever variables it is you're solving for, it's going to equal your inverse matrix times what your equations equal. So that's the 3 by 1. That 3 by 1 matrix is the three values that your equations actually equal in your original problem there. So just remembering lots of multiplication here. We've got a 3 by 3 and a 3 by 1. So your new matrix, your solution, will be a 3 by 1. And that's going to be what your x and y and z will equal. So we just have to do that multiplication. So again, it's your row times your column. So negative 4 times negative 4 is 16. Negative 4.5 times 2 is negative 9. And 2 times negative 1 is negative 2. Then your next row, 1 times negative 4. 1.5 times 2 is 3. 0 times negative 1 is 0. And your last row, 2 times negative 4. 2.5 times 2. Negative 1 times negative 1. So when you guys get what those values are, that's going to be what your x, y, and z is. So 16 minus 9 minus 2 is 5. Negative 4 plus 3 is negative 1. Negative 8 plus 5 is negative 3 plus 1 is negative 2. So that is your x, y, and z. So the process of actually solving, once you know you've actually got the inverse of your coefficient matrix, once you have that inverse, we just multiply it by whatever your equation is equal, and that will be your x, y, and z value. So for the second example here, still using x, y, and z, it's going to equal this inverse matrix here. 1, negative 1, 1, negative 1, 2, negative 4, 1, negative 4, 11, times those three guys, so negative 1, 5, and 6. So again, row times column. So negative 1, negative 5, plus 6. Next row, positive 1, 10, and negative 24. And your last row, negative 1, negative 20, 66. So whatever those values equal will be your x, y, and z. So let's see here. So 0, negative 13, and 45. Okay, so there's a lot to this process, but like I said, we wanted you to practice verifying inverses just so that you kind of understand what it means for something to be an inverse matrix. But then you use that inverse matrix to actually multiply by what your equations equal, and then that will give you guys your x, y, and z, your order triple.